Good day, grade 8 Makati Science High School students. For today, our topic is going to be about congruence and the side-side-side triangle congruence postulate and the side-angle side triangle congruence postulate. But for that, we'll just have a quick review of the properties of equality. This is for the second quarter of our learning area or our subject geometry. Okay, so to start off, we have the first property of equality. We have the reflexive property of equality. It simply states that, for example, we're given here a number or a variable. This specific variable a is equal to itself. So that's the reflexive property of equality. So very logical or tautological. Then we have the symmetric property of equality. It states that when you have a variable that's equal, we have two variables that are equal to each other, a and b. Then if we transpose or we rearrange those two, then we'll have b is equal to a. So that's the symmetric property of equality. Then we have the transitive property of equality. It just simply states that, for example, you have AB is equal to CD. Okay, so let's say those are side measurements. So side measurement AB is equal to CD. And this measurement CD is equal to EF. Then therefore, since AB is equal to CD and CD is equal to EF, therefore we can say from the transitive property of equality that line segment AB is congruent to line segment EF. Okay, and then we have the addition property of equality. So that's just simply adding a specific constant to a specific variable and will yield the same number or the same value. For example, we have here 3x is equal to 15. So if we add both sides, if we add 5 to both sides or any constant, okay, so let's say for example we added 5, okay, so it means to say that both the right hand side and the left hand side are congruent or equal. So 3x plus 5 is equal to 15 plus 5 because we added both 5 to the equation, and we've already established, or it's given, that 3x is equal to 15. So that means both of these right and left hand sides are equal to each other. Okay, then we have the subtraction property of equality. So the addition, it's much like the same as the addition property of equality. So for example, we have here 2y is equal to 20. So instead of adding from the addition property of equality, we will subtract. So let's say for example, we will again think of a constant. Let's say for example 2. Then also we need to put 2 here on the right hand side as our constant to subtract from the value that we have here on our right hand side. So that will be 2y minus 2 is equal to 20 minus 2, or simply 2y minus 2 is equal to 18. So that's a subtraction property of equality. And for the example here, it's 2y minus 4. Okay, then we have the multiplication property of equality. So very simple. So it simply says that if we have here an assumption, a fact, for example, a statement that z is equal to 3, then if we introduce another constant, let's say it's 3, so that's going to be z times 3. Okay, so the right hand side must also be multiplied to 3, so that's going to be 3. So therefore we have here 3z is equal to 9. Okay, so we're just introducing constants. Okay, so that's the pattern here, and technically it just means that whatever constant that we introduce, we also get the same value, or the proposition still holds true after we've introduced a constant. Okay, then we have the division property of equality. So let's say for example we have two variables, so we have s and t. So if we have r there, r must not be equal to 0, then we can say that s over r, okay, since s and t are equal, is equal to t over r, given that our value of r is not equal to 0. Okay, then we have after the division property of equality, we have the distributive property of equality. So from the word distribute, okay, we're just going to distribute whatever constant or variable is outside a given parentheses or bracket. Okay, so let's say for example we have here, for our example, 7 times quantity g plus h. Okay, so that means we simply distribute 7, okay, to both g and h, and therefore we get 7g plus 7h as our answer here for our distributive property of equality. And then we have the associative property of equality. So this only works for addition and multiplication. So let's say, for example, we have here these values, 5 and then x and then 3. Okay, and then we have here for both sides again 5, x, and then 3. So the associative property of equality works like a grouping. Okay, so a grouping equality. So it just basically says that if we have here the addition property of equality for associative property, then it says that 5 plus x, quantity 5 plus x plus 3 is equal to 5 plus quantity x plus 3. Okay, so we're just regrouping variables, and essentially this will only give you for both sides x plus 8. Okay, so this property holds true. Okay, it's kind of like just a grouping property for our properties of equality. And then we also have the commutative property of equality. So it also works like the symmetric property of equality, but here, okay, it measures, or it has two variables or two values. So for example, we have here a and b. Okay, so a and b are variables for this commutative property of equality. It basically means that if we add a plus b, okay, so it must be equal to b plus a, regardless of their value. Let's say it's 1, 2, or 3, okay, given that a and b also have different values or also the same values. And also it also works for multiplication, so not just addition. Okay, so we can try to plug in some values. Okay, so let's say for example this is 2 and this is 1. Okay, so 2 plus 1, that's 3. You're also going to get 1 plus 2, which is also 3. And then from here, so also have 2 times 1, which is also 2, and 1 times 2, we also get 2. Okay, and then we have the 11th property. So that's the inverse property of equality. So it essentially states that if you have here a certain variable or a certain value, if you add its inverse, you always get a 0. Okay, so the inverse is kind of like the opposite of the number. So let's say for example we have here -2. So what's the inverse of -2? So it's +2, and if you add -2 and +2, you'll get a 0. And for multiplication, it also works, but the answer must be equal to 1. For example, we have here a, the variable a, and if you multiply it to its reciprocal, okay, which is 1 over a, we get 1. So whatever value that we put there, it will always be equal to 1. So if let's say for example you have here -4, and we multiply that to 1 over -4, which is its reciprocal, you also get a 1. And then lastly, we have the identity property of equality. So that simply means if we add a 0 to a specific value or a number or a constant or a variable, you get the value or the constant or the variable that you have. So this is going to be also a. And then for multiplication, whatever we multiply, okay, whatever we multiply to a specific value, we also get the constant or the variable itself. For here we added 0, a plus 0, we got a, and then for here we multiplied 1 to the variable or the given value, we also got a. Okay, so we can extend the use of these properties to geometry, and especially when we're dealing with two-column proofs. Okay, so and our topic especially is on congruence. We're going to use these proofs, these properties extensively. So we have here the three properties that we're going to use a lot here in our discussion. So we have here the reflexive property of congruence. So it also works like the reflexive property of equality, but for here we have here the congruent symbols. Okay, so we're going to see a lot more of these congruent symbols here in our topic, in our future topics here in geometry. And also we have here the symmetric property of congruence, which also works as or also the same. It also works the same as the symmetric property of equality. Okay, but instead of having an equals, we have here the congruence. And also we have the transitive property of congruent. So okay, so this is quite new. Okay, so the transitive property of congruent works like if A is equal to B and B is equal to C, then A is equal to C. Okay, so that also works like the transitive property of equality. Okay, so these they all share the same, okay, they all share the same the same properties, okay, but for the congruence, we have here, instead of an equal sign, we have the congruent signs. Okay, so that's basically the foundation of the two-column proofs that we're going to use for our subject here in geometry. Okay, so now we move on to the topic of congruence and correspondence. So when we say that, when we say that two figures are congruent in geometry, so it is defined by any type of geometrical figure that has the same shape and size. So we have, for example, any type of geometrical figures. Okay, so we need to compare two geometrical figures, and we want to know if they have the same shape and size, and therefore if we conclude that they have the same shape and size, we can say that both of those geometrical figures are congruent. So for example, we have here parallelogram BORG. Okay, so it could be congruent to parallelogram MSDE. Okay, and correspondence works differently from congruence. So if in congruence, the things or the properties that we're looking for is the same shape and the same size, so they have to have the same parameters, the same side measurements, the same angle measurements in order for them to be congruent. Correspondence takes into account the different the different elements of the shape. For example, we have here the parallelogram BORG. So it's different elements, or it's different parts. We have here the vertices, the four vertices BORG. There are four corresponding vertices. There are four vertices that correspond to that to parallelogram DSME. So for example, we have here point O. Okay, so we have here point O, so it corresponds, okay, point O corresponds to point S, okay, because those parallelograms have been flipped. Okay, so okay, point O corresponds to point S. Same goes with point R and point T. Okay, so the symbol for congruence, guys, is this one. Okay, so we're very familiar with that one. Okay, and the symbol for correspondence. Okay, so if you want to show that points R and D are corresponding, so we can have the symbol R corresponds to D. Okay, so it's kind of like a line symbol. Okay, so it's kind of like a segment, and then we have these two arrows, two left and right arrows. Okay, so there you go. R corresponds to D, and also that's not just the points. We can also say that those are the angles. So angle O corresponds to angle S, and angle R corresponds to angle D. And also we can do it for segments. Okay, so we can say that side OR, okay, side OR corresponds, okay, side OR corresponds to side DS. Okay, and we can also say that side BG, okay, side BG corresponds to, okay, corresponds to side EM. Okay. Okay, here, so for our figure here, we labeled some parts. We can say that angle O, okay, for our figure here, we can say that angle O is congruent to angle S. So how can we say that? Because these two angles right here, if we can see, they have these markings. Okay, so if you see those markings, that's the symbol, or one of the representations or symbol that signifies or means that they're the same or they're congruent. Okay, so we can also say that angle E, okay, angle E is congruent to angle G. Okay, and we can also say that side measurement or line segment RG is congruent to line segment D. Okay, and we can also say that line segment OB, okay, is congruent to, okay, line segment SM. Okay, for correspondence, okay, a while ago we've already mentioned corresponding parts, but we can try to say, okay, so we can try to say that angle O also corresponds, okay, to angle S, and angle E, okay, also corresponds to angle G, and so on and so forth. Okay, so those are our properties for congruence and correspondence.